According to Article 100 of the 2005 National Electrical Code, a dual-fed service is defined as a service with two sets of service entrance conductors to one or more service disconnecting means, providing normal and emergency sources of supply. Based on this definition, a backup generator and a service feeder from a local utility would not typically be considered a dual-fed service. This is because a dual-fed service requires two sets of service entrance conductors feeding into a single service disconnecting means, which is not the setup in a standard backup generator configuration where the generator serves as an alternate power source rather than a simultaneous feed. Because the generator is not considered a separately derived system, you cannot connect the grounds from the service and the generator to a common point, such as the equipment ground at the generator. The National Electrical Code provides specific guidance on grounding for generator systems to ensure safety and proper operation. Several sections of the 2005 National Electrical Code are relevant to grounding for generator systems. Section 250.30. 8.1 requires the ground rod to be connected to the generator frame. This ensures that the generator itself is properly grounded. Section 250.32. D prohibits the connection of the generator neutral to the service neutral when the generator is not operated as a separately derived system. This is to prevent circulating currents and potential ground loops. Section 250.32. E requires a grounded conductor, which is the neutral, to be installed between the generator and the service disconnect if the generator neutral is not connected to the service neutral. This provides a path for fault current to return to the source. In summary, you cannot connect the grounds from the service and the generator to a common point in the described setup, and the system is not considered a dual-fed service according to the National Electrical Code. It is always recommended to consult with a qualified electrician to ensure that all electrical work complies with the latest codes and safety standards, as electrical codes can change and interpretations may vary. Understanding the distinctions between different types of electrical services and grounding requirements is crucial for ensuring electrical safety and compliance. Properly grounding a generator is essential for protecting against electrical shock and ensuring the reliable operation of electrical equipment. A ground rod provides a path for fault current to flow back to the source, tripping a circuit breaker and energizing the circuit. An ungrounded system can lead to dangerous voltage levels on equipment enclosures, posing a significant safety hazard. The installation of a grounding electrode system is a critical step in providing a safe and effective ground. This system typically includes ground rods, ground rings, or other approved grounding electrodes. The grounding electrode system should be bonded to the equipment grounding conductors, which are connected to the metal enclosures of electrical equipment. This creates a low impedance path for fault current to flow back to the source. Regular inspection and maintenance of the grounding system is essential to ensure its continued effectiveness. Ground connections should be checked for corrosion or damage, and the grounding electrodes should be tested to verify their resistance to ground. Any deficiencies should be corrected promptly to maintain the integrity of the grounding system. When working with electrical systems, it is important to follow all applicable safety precautions, including wearing appropriate personal protective equipment, using insulated tools, and de-energizing circuits before working on them. Only qualified and licensed electricians should perform electrical work. The National Electrical Code provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the installation of grounding electrodes, and the bonding of metal enclosures. Adherence to these requirements is essential for ensuring electrical safety. Understanding the specific requirements for grounding generators is crucial for ensuring their safe and reliable operation. Generators can be connected to electrical systems in a variety of ways, including through transfer switches, which allow for seamless switching between the utility power and the generator power. The grounding requirements for generators depend on how they are connected to the electrical system. Separately derived systems require different grounding configurations compared to non-separately derived systems. In a separately derived system, the generator is considered a new source of power, and it must be grounded accordingly. This typically involves installing a grounding electrode system at the generator and bonding the generator neutral to the grounding electrode. In a non-separately derived system, the generator is connected to the existing electrical system, and the grounding requirements are different. In this case, the generator neutral is typically not connected to the grounding electrode, and the grounding is provided by the existing grounding system. The National Electrical Code provides specific requirements for grounding both separately derived and non-separately derived generator systems. These requirements are designed to ensure that the grounding system is effective in protecting against electrical shock and ensuring the reliable operation of electrical equipment.